Hi everyone, welcome to Pre-Calculus Lesson 2.7, one-to-one functions and their inverses. So the first thing we're going to explore is what is an inverse and what does it mean for a function to be one-to-one. So let's take a look at some definitions. An inverse is a rule that acts on the output of a function to produce the input. It's basically an undo button for the function. So that means that if I have the function 2x, its inverse function would be x divided by 2, because multiplying by 2 and dividing by 2 are opposite operations. So if I take the output values from the 2x and I put them into x divided by 2, it will give me those original input values. So let me show you an example that would illustrate this. The function that I picked is x plus 2. And what I did is I took the x values 1, 2, and 3, and I evaluated this function for those, and I got 3, 4, and 5. Now, its inverse function is x minus 2. So if I take these output values, 3, 4, and 5, and I put them into this function, it will get me 1, 2, and 3, which were the input values of this. So this function, f inverse of x, undoes the x plus 2. It is the inverse of it. If I take these outputs and put them into this function, it will tell me what the input values were. Now, this only works if a function is one-to-one. And that means that this is going to be a function where each output is only generated by one input. So let me show you what that means. I have two mapping diagrams here. In the first one, this function is one-to-one because each x value goes to a very specific y value, and each y value goes to a specific x value. If I tell you that y is 4, you can tell me that the x value was 2. In the second mapping diagram, notice each x value goes to one y value, so that makes it a function. But if I try and go the other way and I tell you the y value was 3, you can't tell me which x value it was. So that makes this not one-to-one, although it is a function. And the way we can check to see if this is true is we can use the horizontal line test on a graph. So if you graph it and you draw a horizontal line, it should only touch the function once, no matter where you put the horizontal line. If a function is only ever increasing or only ever decreasing, then that makes it one-to-one. So you don't have to worry about it if you know it's always going to increase or always going to decrease. And if you have a function that's not one-to-one, sometimes we can restrict the domain and say, just look at the positive x values, or just look at the negative x values, or just look at the x values from 1 to 2. So if we restrict the domain, then we can turn a function into a one-to-one function that normally would not be one-to-one. So let's take a look at some examples of graphs, and we'll see if we can determine if they're one-to-one. In this example, they want to know if f of x equals x cubed and g of x equals x squared are one-to-one. So what we're going to do is we're going to take a look at their graphs and we're going to use a horizontal line test. So I have this lovely horizontal line, and all I have to do is drag it along the graph. Notice it's only ever touching the graph once, no matter where I put it. Now it does flatten out at 0, but it isn't actually flat. There aren't any two x values that have the same y value. So it is always increasing. It is one-to-one because that line only ever touches once. Now in this graph, notice it touches once at 0, 0, but no matter where else I put it, it's touching in two different spots. So like here at 4, I have the point negative 2, 2, and positive 2, 2. 4. The y values are 4 there. So that is not one-to-one. Now let's take a look at an example where they're asking us to actually evaluate an inverse. And remember, the inverse is going to give the input when you put in an output. Okay, so they told us that f of 1 is 5, f of 3 is 7, and f of 8 is negative 10. So they want us to find the next few things. So f inverse of 5. I go up here and I find an output of 5, and I name the input. The input was 1. So what you're going to do is you're going to try the other two and then press play to see if you're right. So pause the video, try them, and press play. So f inverse of 7 is 3 because the output is 7, the input was 3. 3 is the answer. And f inverse of negative 10, I find the output of negative 10, the input was 8. So the answer here is 8. So let's talk about inverse functions a little more deeply. Now the notation for an inverse function is this. It looks like f to the negative 1, it looks like an exponent, but because this is function notation, it's actually a way of saying that this function is an inverse. Now, as I said earlier, the inverse is the function that takes the range, the output values, and produces the input values. So this means if I was going to graph it, I'm going to switch the x and y values because the previous input is now my output. So it's switching those. Now, to create the inverse function, and these steps are interchangeable, you switch the x and the f of x and you solve for f of x. And we'll go through quite a few examples of doing that so you can get the hang of it. Now, if I'm graphing an inverse, I reverse the xy pairs and it will produce a reflection of the graph across the line y equals x. So we're going to have some examples showing how all of this works. But first, let's talk about the inverse function property. The inverse function property is something that is really important to know. So I would highlight it in your notes. I would underline it. Make sure that it's something that's really obvious and that you study because it's something that's really important. What it says is that if you do a composite of the inverse on the normal function, you're going to get x. And if you do a composite of the normal function on the inverse, you're still going to get x. So you have to show both composites. And here I just wrote it in terms of f and g. If you do f of g and g of f, and you get x both times, then you know that the two functions are inverses. You have to show both, though. You cannot show only one of those. So let me show you how this works. Okay, this says to show that f of x equals x cubed and g of x equals x to the 1/3 are inverses of each other. So what we're going to do is we're going to do f of g. So I'm going to take the g function and put it into the f function. And that looks like this. Okay, so f of g, you get x to the 1/3 cubed. And you multiply those exponents and it comes out to x to the first power. Now we're going to do g of f. I'm going to take the f function and put it into the g function. And I get this. So x cubed to the 1/3 power, you multiply the exponents and you get x. Now I got x both times. So that means that the inverse function property is true. So I can write a summary statement saying that f and g are inverses by the inverse function property because I got x both times. Now we have a few more examples for this lesson, but I'm going to put them in a separate video. So don't miss that video and don't forget to be taking notes.